In lesson 2.6, we're now considering surface area and volume of three-dimensional figures. And the solids that we're looking at are these that are listed. They're found in your textbook, and I've just pasted that here on this slide. I just wanted to point out a few things. V represents the volume. Okay, so for rectangular solids such as this, you've got length, width, and height. That's the L, W, and H. The cube is each edge measures the same, so that's why that's labeled as an E. Then for the right circular cylinder, you're looking at pi r squared times H. H is the height of the cylinder. For a right prism, now that's this figure here. Let me see if I can highlight it here. That's this figure, the right prism. And with a right prism, they talk about the area of the base times the height, because the bases, like in this case, the base is this hexagon shape up here at the top or at the bottom. That's the base. So you have to find the area of that base and then multiply it times the height of the solid. And the base may not always be a hexagon. It might be a square base, or it might be a triangle base, or something like that. So that capital B stands for area of the base. Now, under surface area, the P stands for perimeter of the base. Okay, and this is mentioned up here at the top too in these formulas that are listed. For a right circular cone, that's this figure, the 2.116. And a regular pyramid, here again, notice it's got a capital B. That means the area of the base. So the base of the pyramid could be a square, it might be a triangle, it might be a hexagon, that sort of thing. The sphere is a solid in which both the surface area and the volume are based on the radius of that. And then the last one is the frustum of a right circular cone. And notice here that there are two R's. There's a capital R and a lowercase r in this formula when you're looking at both these formulas for the surface area and the volume. The capital R is the radius of the larger circular base, whereas the lowercase r is the radius of the smaller one. So anyway, that's the formulas that we're going to be using. I'd like to look at one example with you here. And in this one, we're considering a propane tank. And the shape of this propane tank is that of a cylinder with a hemisphere at each end. So if you've got two hemispheres, one at each end, when we join those two together, it's going to make one sphere. Okay, so to find the area of those here, these two hemispheres here, I'm going to kind of shade these out a little bit here. This is one half of the sphere, and this is the other half. So we're going to be using this formula, 4/3 pi r cubed. And to find the volume of the cylinder, well, for that one, we're going to be using this as the height. Okay, and then the base is, you have to kind of visualize this. This is like a little circular base here going on for the cylinder on both ends. Okay, so the volume of the cylinder is pi times radius squared times the height. Okay, so we're going to be using these two formulas to solve this problem. So to find the volume for the tank, we need to find these two volumes. So all I've done is recopy the formulas here. And then it's a matter of plugging in values. So for the radius for the tank for this cylinder, we're going to be looking at a segment that goes from the center of the circle to a point on the circle. Okay, so we need that length. That's the radius. Well, in the problem, they tell us the distance from here to here all the way across is 4 feet. So this radius then has got to be 2 feet. Okay. And so we're going to plug that in for r squared, so that's 2 squared. The height of the cylinder, if we set this thing up right, that would be this measurement here. Okay, so the height is 6.50. And then for the two hemispheres that are put together, we're going to look at a sphere. So that's 4/3 pi times, here again, the radius of this hemisphere, from the distance from the center to a point on the sphere itself is 2.00, and we're going to raise that to the third power. So this is going to be the volume of the cylinder. This is the volume of the sphere that's formed with the two hemispheres. We plug all this stuff into our calculator, and our final answer ends up being this. Now, I'm just now seeing a mistake on this slide. Do you see it as well? It says volume is feet squared. We know that can't be right. So the volume's got to be feet cubed. So 115.19 feet cubed should be our final answer.